Okay, so we'll try this again. Evidently, the link was the wrong link for this particular set of problems. So we'll give this one more shot. So we'll kick off from problem number 16. So in problem 16, this is one of those problems where we wanted you to be able to just read the information and generate a picture based on what you're told. So it says N is the perpendicular bisector of AB. So let's see. So if I started with AB right here, and it's supposed to be the perpendicular bisector, so that means it's going to hit at a perpendicular. And remember, you can use a lowercase cursive way to name a line. And it says, and intersects at point P. Well, if that's true, then that would mean by definition of bisector that AP and BP in fact are the same. So that's 100% a true statement. However, saying that the distance from A to B, which is the entire distance, is the same as the distance from B to P would not be true. Now, carrying that on a little bit further, is it true that if you double the different distance from B to P, that twice this value would be the entire thing? That would in fact be true. Now, one thing I would feel a little bit better is if we said it this way. It really should be 2BP equals AB, and that's a subtle thing, but you can talk about segments being congruent, but really, when we're going to double something, you have to really be thinking about that as a numerical value. And so I'd have to double the value from B to P to get AB. Okay, so moving on to number 17. Remember, proofs generally start with the given information, and we haven't violated that, but it does happen occasionally in math where you start with something even a little bit more basic, but this is fine. Now, I happen to know that Z and Y are congruent because of the vertical angle theorem. But the nice thing about this is we did give you a hint, and that's the transitive property. And so if you recall, the transitive property from back in the day said if A equals B and B equals C, then you could use this B right here like a bridge. Then you could use the transitive property to say A is the same as C. That's usually how it's used in math classes. So in this case, notice B is the bridge. Here, Z is the bridge. So if W is the same as Z, but in turn Z is the same as Y, I could jump and say W and Y would have to be the same. And if you look at the picture, that's really, really helpful because here's W and here's Y. Well, those are called corresponding angles. And so I now could say that M and N are parallel because the converse or the reverse of the parallel of the corresponding angle postulate. Corresponding angle postulate. So remember, postulates are something that you cannot prove, but you know to be true. And this is one of those things. So remember, the normal story talked about we know that they're parallel and therefore we know something about the angles. This is going backwards and saying if we know about the angles, can we also determine that those are parallel? Now that gets us to the last little piece is that parallel lines right here have to have exactly the same slope. So I want a slope of 2/3, whereas here, if we want perpendicular, we want a slope that is opposite and reciprocal. So the opposite of positive a half is negative a half, and the reciprocal is 2/1. So if we were to go ahead and write y equals mx plus b, which is the slope-intercept value, we were given the slope right here by understanding parallel and perpendicular, but we have the intercept because it said so. So my slope-intercept form of a line would be right here because I have the matching slope, but I have the y-intercept that I desired. And over here, we have the slope that I want. And you don't have to write 2/1. You can just write -2. And the y-intercept, of course, is 5. And there's my slope-intercept again. So pretty quick little video for problems 16 through 18. And I hope that was good. We'll see you back in class. Bye-bye.